All right, class. If you notice now, we're in the second half of chapter 4, and we've talked about adding and subtracting, and we've been talking, now we're going to move into the area of multiplication. So if you look at section 4 or 5, we're going to multiply polynomials by monomials. Now remember, a polynomial is just a string of terms that are separated by plus signs and minus signs, and we're going to multiply them by monomials. But before we get started, let's review those two rules of exponents that we've been looking at over the last two sections. So if you look here, what we learned in section 4.4 was the rule of exponents for a power of a power. Remember, that's what Mrs. Burton likes to call it. And if I've got power to a power, I've got a base raised to an exponent inside my parentheses, and then it is also raised to another exponent. And so we saw that when I have a power raised to a power, that we take those two exponents that are hanging out up there and we multiply them together. So this would be a raised to the 3x. The rule of exponents that we learned in section 4.3 was called power of a product. And basically we saw if I multiply x to the nth power times x to the 5th power, well, I realize, hey, they're the same base. And so if I have the same base, then all I have to do is add my exponents. So if I look here, what is n plus 5? And we're going to say, oh yeah, that's going to be x raised to the n plus 5. Again, they're the same base. I add my exponents. And if I look there, I don't have a like term, so it's just n plus 5. So really what we're going to be doing right now is what I would call distributive property. Now, we worked with distributive property back in chapter 2. And remember, that's when we had a monomial on the outside of my parentheses, and I took it and I multiplied by everything on the inside of the parentheses. But if you remember, when we were back in chapter 2, what we had outside of the parentheses was a number. But now that I can have a letter outside as well. So if I look here, and I wanted to take care of this little example, we would say, okay, y times y gives me y squared, and then y times 3 is 3y. And we did that a lot back in chapter 2. So let's do a few of these and see what that means as we go through chapter 4. Now, you're going to have to slow down a little bit and be very careful. We're going to have to watch out with our signs, and we're going to have to watch out with our exponents. But if we look up here, my monomial on the outside of the parenthesis is negative z. We're going to multiply this by this binomial. And so now we're going to take negative z times 6. Well, that gives me what? Negative 6z. And now let's go back and multiply negative z times negative 5z. And that's going to give me positive 5z squared. Now, sometimes on your homework, they're going to write them vertically instead. This is the exact same problem, just written a different way. We're used to doing distributive property inside the parentheses and out of the parentheses, but we would actually do this problem the same way. We would say negative z times 6 is negative 6z, and then we would multiply negative z times negative 5z and get positive 5z squared. So we do it the exact same way. They just may give us the information in different arrangements. Let's look at number 2. Our monomial on the outside is 4t. We're going to multiply by this trinomial. So we're going to multiply what's on the outside by everybody on the inside. So 4t times 2t squared. Oh, we got a letter thing and a number thing. 4 times 2 is 8. T times t squared is t cubed. Now we're going to do 4t times negative t, which is negative 4t squared. and we've got to do 4t times negative 5. The last term there is going to give me negative 20t. Now, can I combine all those together? They're all t's. That's right. Those are not like terms. Remember, they have to have the exact same letter, but they also have to have the exact same exponent. So when I get done with problem number 2, that's my final answer. Let's look at one more of these. Oh, I throw a fraction in on you. So let's see what happens here. What's 1/2 of 4? You're going to say 2. S squared t times t squared. We're going to have s squared t cubed. Now we're going to take 1/2 of negative 10, which is negative 5. And then we're going to look at the letters, and we're going to get s cubed t squared. And now we're going to take 1/2 of 6. 1/2 of 6 is 3, and if I look at my letters, we've got s to the 4th, and t comes along for the ride. Okay, so we're taking the monomial on the outside, and we're multiplying it by all the terms inside. Good job. Okay, let's look at number 1. Have we had to do distributive property times 2 before? Of course we have. Okay, so let's look up here, and let's go ahead and multiply 4y times this binomial right here. So 4 times 2 is 8. Y times y squared is y cubed. Now we're going to do 4y times negative 3y. That's going to be negative 12y squared. Oh, do you see my red flags waving here? There's my minus sign in front. So that means we're going to multiply by negative 3. So negative 3y squared times y is negative 3y cubed. Negative 3 times negative 4 is positive 12y squared. Oh, now we took care of all our distributive property. Now, what should we do next? That's right, we need to combine like terms. So who's going to combine with 8y cubed? Yeah, that's right. We've got negative 3y cubed. They are like terms. So remember, we're just going to look at the coefficients out in front. 8 and negative 3 is 5y cubed. And then now let's look at our y squareds. Did you notice they are inverses of each other? These guys actually cancel out. So my final answer is just 5y cubed. Great job. All right, let's look at number 2. Let's get rid of all this writing so it doesn't confuse us. Oh, do you see I gave you a parenthesis inside a bracket? When we have all these grouping symbols, what did we learn to do back in chapter 2? That's right, we start on the inside and work our way out. So what do we need to do first inside the brackets? Oh, do you see my red flags waving there? So we're going to have 3x, and we're going to multiply, use our distributive property. Negative 2 times 3 is negative 6. Negative 2 times x is negative 2x, and that's still in my brackets. Now, do you notice we're not done in the brackets yet? I can combine like terms there. So we've got 3x minus 2x is x minus 6. Now what's left? We've got this in front of the bracket, and then minus x squared. So what do you think we should do next? What does order of operations say we need to take care of next? That's right. We need to take care of our distributive property. 2x times x is 2x squared. 2x times negative 6 is negative 12x. And we've still got that minus x squared on the end outside of my brackets. Very good. Now we're going to collect like terms. I'm running out of room. I'll come over here. What's 2x squared minus x squared? That's right. We've got x squared minus 12x. Are they like terms? No, they're not. So that's my final answer. I can't collect like terms because they are not like terms. Good job. All right. Oh, I'm changing it up. Now it says solve. Do you notice these have equal signs in them? The others said simplify. There were no equal signs. If I'm going to solve, Remember, isolate the variable by inverse operations. So let's go ahead and take care of our distributive property. On the right side, we've got 0 equals 3 times 1 is 3. 3 times negative 2t is negative 6t. And I've got negative 5 times 2 is negative 10. And negative 5 times negative t is positive 5t. Nice. Okay, let's collect like terms. We've got negative 6t and positive 5t, which is negative t. And then we've got 3 and negative 10, which is negative 7. Now, who do we need to move to get letters on one side and numbers on the other? Yeah, all I need to do is add t to both sides. If I add t to both sides, we're left with t equals negative 7. And that's my final answer. I isolated the variable. I've got letters on one side, numbers on the other. Very nice. Okay, let's go ahead and try number 2 together. Let's try number 2. We've got distributive property again. So the 4 on the outside multiplied by everybody on the inside. So 4 times 3a is 12a. 4 times negative 1 is negative 4. We've got negative 5 times 1, which is negative 5. And negative 5 times negative a, which is positive 5a. And negative times a negative is a positive, equals 8. Let's combine like terms. Well, we've got 12a and 5a, which gives me 17a. And negative 4 and negative 5 is minus 9, equals 18. Who's my floater this time? Oh, 9. So let's add 9 to both sides. So now I've got, that should just be an 8. Okay? I've got 17a equals 17. And if I divide both sides by 17, we get a equals 1. And that's my final answer. Now, what would happen if I gave you some fractions? We've got some fractions here. Sometimes, remember, we have a fraction that's going to be our monomial that we're going to multiply everything by. So let's look and see what happens. If I take 1/2 times 12, well, 1/2 of 12 is 6. 1/2 of 4, negative 2s squared. And now we've got negative 2 times 1, which is negative 2s. And negative 2 times negative s is positive 2s squared, equals 8. Now, if we go to combine like terms, did you notice something? Yeah, I've got negative 2s squared and positive 2s squared. Those are inverses of each other. They cancel each other out. And we're left with 6 minus 2s equals 8. Who's my floater? That's right, 6. We're going to subtract 6 from both sides. We're still using those properties of equality. This cancels, so we've got negative 2s equals 8, and negative 6 is 2. And if I divide both sides by negative 2 to get s alone, we get s equals negative 1. All right, everybody try this one. Everybody try the next one here. Oh, I gave you a lot of fractions. Let me give you a couple minutes and let's see what happens. Okay, so I'm going to multiply by 1/2. And then I'm going to multiply by negative 2. Hopefully you see those 2's are going to cancel out there and give me a negative 5. Over here, we're going to have 6 minus 2c. Now, when you took care of all your distributive property, does yours look like mine? Good job. Let's combine like terms. 3c minus 2c gives me c. Negative 2 and negative 5 gives me negative 7 equals 6 minus 2c. Oh, now we're back to problems that we did back in chapter 3. Remember when we had C's on both sides of the equal? We're back to chapter 3. So I'm going to get my C's out in front. So I've got 3C minus 7 equals 6. I'm going to add 7 to get rid of my floater. So 3C equals 13. What do I need to do to get C alone? Yep, got to divide both sides by 3. So my answer is actually an improper fraction this time. Okay, so words of wisdom from Mrs. Burton. Slow down. Be intentional and deliberate as you go through and multiply. Great job.